Hello friends, we are still not employed by FAANG company, so let's not stop lead coding till we get there. Today we are going to do the number one problem inside the lead to code, which is to some problem. And this question has been literally asked by hundreds of companies hundreds of times. Any company that you want to get a job of at least have asked this question at some point in their history. If we see the list of companies, it's like Amazon, Adobe, Google, Apple, Microsoft, Facebook, Bloomberg, Uber, Expedia, Spotify, Goldman Sachs, and then also companies like TCS, SAP, Square, Snapchat, ByteDance, Twitter, ServiceNow, and these are just some of the companies that are my dream companies that have already asked this problem, and that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and probably the most like problem on LeetCode. Basically, we are given an integer array of numbers, and we are also given an integer value target, and we need to return the indices of two numbers such that they sum up to this target value that we are given. So if we try to understand this with an example, suppose we are given the values like 2, 7, 11 and 15, and we are also given a target value is 9. So in this case, we can clearly see that this 2 and 7, if we sum that up, it becomes 9. And that's why in this case, we need to return the index values of this one. So index values would be 0 and 1, and this would be the answer we need to return. Also, in the another example, we are given the values as 3, 2 and 4, and we are given the target value to be 6. Now because the target value is 6, we can actually do 3 plus 3 equals to 6 as well in this case, but this is not the correct approach because we only have 1 3 and we don't have the other 3. So this would not be the correct solution. The correct solution would actually be 2 plus 4. So if we do 2 plus 4, it would become the 6. So that's why in this case we will need to return the index value as 1 and 2, and this would be the answer. It's really easy to understand the problem statement. Let's see that what could be the different approaches to solve this problem. Okay, so first of all, we are going to solve this in brute force way, and the idea is that at any point we are iterating over, we need to find that what is the remaining value from this target number. So suppose we are checking that whether 1 exists in a pair that sums up to this value number 13. What we are going to do is we are going to do 13 minus 1, so we'll get the remaining value as 12. Now we need to check that whether inside the remaining portion of the array, whether this 12 exists or not. So if 12 exists, we can actually return the index values, but in this case 12 does not exist. If we iterate over all the values, so we can simply return simply ignore this first case, saying that there exists no pair where 1 is part of it which sums up to 13. Now we will start repeating the same process for the remaining values. So now we are at this value number 8. Again we will do 13 minus 8, so the value becomes 5. Now we will check that whether this 5 exists inside the remaining array. So we will check the remaining values, and we can see that 5 already exists over here. So because 5 exists over here and 8 also exists over here, we can return the index values. So in this case, the index value for 8 is going to be 1, and index value for this 5 is going to be 4, and this would be our answer. So this solution would work perfectly fine, but what is the issue with this solution is actually the time complexity is going to be big O of n square. Why n square? Because notice that for every single element we will have to check all the other elements that whether a certain remaining value exists or not, and we could repeating the same process for all the elements. So that's why this is the big O of n square time complexity. The question is, can we do something better? And the answer is yes. Let me quickly show you how. Okay, so we will use the same example. Now previously we know that in the brute force we were doing big O of n square time complexity. Why? Because at every single element, if we wanted to find that, okay, for the remaining value this is going to be 13 minus 1, the remaining value is going to be 12. So in order for us to find this remaining value, we had to iterate over all the places inside the given input array. But what if we can shorten that time? And one way to do is that whatever this given input is, currently it is unsorted. If we sort this given input, so the sorted value or the sorted array would become something like this: 1, 2, 5, 8 and 15. Now this is the sorted array. Now what we are going to do is our target is still going to be this value number 13, but rather than checking those remaining values inside this given original input, we are actually going to do it inside the sorted input. And let me quickly show you how. So first of all, we are going to do, okay, this value is 1, so we are going to do 13 minus 1, so the remaining value is 12. Now we need to find that whether 12 exists inside the sorted array, and this can be done actually in log n time. Why? Because we are going to do binary search. Because this array is sorted And we know that binary search actually takes log n time, which we can do it pretty quickly. So immediately we identify that okay, 12 does not exist inside this given array, so we will ignore this and we will move with the next element. So now this 1 does not need it to be tested. We will check for this value number 2. So we will do 13 minus 2. So 13 minus 2 is actually going to be 11. So 11 also does not exist, and because 11 does not exist, we can ignore this value number 2 as well. Now again we will check for this value number 5. So when we do 13 minus this value number 5, the remaining value becomes 8, and we can clearly see that okay, 8 exists inside this given sorted array, and because 8 and 5 exist, all we need to do is we need to return the index values. So then we will iterate over this given input, and we will try to find the index values of this 8 and 5, which we can actually do it in big O of n time, and that we can simply return whatever the index value is, and that would be our solution. So this approach is actually much better improvement than whatever our brute force approach was, which had big O of n square time. But what are the issues with this approach? So if we see the time complexity in this case, the time complexity is actually going to be big O of n log n to convert this original input from its original form to the sorted form. And then it takes log n time to perform binary search, and then it takes big O of n time to find the index values. But all of that can be generalized to say that okay, we need to complete this in big O of n log n time. Now the question is, can we do something better, and can we do it in a linear time? And the answer is yes. Let me quickly show it to you how. Okay, so again we are going to use the same example, and what we are going to do is we are going to use a hash map. Now inside the hash map, we are actually going to store two items as key value pair. So as the key, we are going to store the numbers inside this given array. So we are going to store numbers as a key, and we are going to store the index values as the values for those particular numbers. And what we are going to do is, first of all, we are going to do, okay, at any position we are going to find the remaining value. So we are going to do 13 minus 1, so the remaining value in this case is going to be 12. And now we will try to see whether this 12 exists inside this given hash map, and that can be done in constant time, because that is the property of hash map, that is the beauty of hash map. So we will try to see, okay, so 12 does not exist in this case. So because 12 does not exist, we will add this value and its index position to this hash map to see that whether in future we can use it or not. So we will add the value as 1, and we will add the index value as 0. Again we will repeat the same process. So now we will move on to the next value. So the next value in this case is going to be value number 8. So 13 minus 8, the remaining value is 5, but 5 does not exist inside the hash map yet. So we will add an entry for this value number 8 and its index position as 1. Again we will move on to the next value. The next value is 15, so we'll do 13 minus 15. So 13 minus 15 is actually minus 2, and minus 2 does not exist over here. So again we will add the value number 15 to our hash map. So we will add an entry called 15, and the index value is 2. Again for this 2, the 11 does not exist, so we'll add an entry for this 2, and the index value is 3. Now when we are at this value number 5, we will do 13 minus 5. So 13 minus 5 gives us the value as 8. Now in the hash map, we can clearly see that 8 exists over here, and its index position is this one, and we are iterating this 5, so we know that what is the index value of this 5. So we can clearly return the value of this pair as 1 and 4, which is the corresponding index values of this 8 and 5, and that would be our solution, and this answer would be the perfect solution. If we see the time and space complexity in this case, the time complexity is actually going to be big O of n. Why? Because we are iterating over this given input just once, we don't have to do anything else. If we see the space complexity in this case, the space complexity is also going to be big O of n, because we have to create this additional hash map, and we have to enter all the numbers that are present inside this given hash map, inside this given array, and this would be the most optimal solution. Let's move on to coding now. So first of all, we will create a hash map to store the integer values. Once that is done, we will create a for loop, and we will iterate over the given input. And first of all, we will calculate a variable called difference, and for this difference variable, we will do target minus whatever the current value from the array we are at. And then we have to check that if the value exists inside the hash map that we have created. If it does exist, we can actually return, and if the value does not exist, we can actually add that entry to our hash map. And now out of the loop we'll simply return null, because then otherwise it will give us an error. Let's try to run this code. Okay, seems like our solution is working. Let's try to submit the code. And our solution is actually pretty efficient. It's almost like 99% faster than all the other solutions, and I would be posting this in the comments so you can check it out from there. Also, I have created a GitHub repository where I have stored the solutions of all the problems that I have done so far, and I would be posting this link inside the description as well, so you can check it out from there. I have made it public so anyone can use it.